Welcome to the training of medium voltage switchgear complete guide. So in this training, we will learn about the medium voltage switchgear. We will discover different components of medium voltage switchgear, and we will different arrangement of medium voltage switchgear. So I will be guiding you throughout this training. I have almost 18 years of experience in the field of power system production, and I have worked in different countries, different utilities. I have worked from the medium voltage level to extra high voltage level of 500 kVs. So I will make sure in my training that you will learn all the practical aspects of the medium voltage switchgear, because I have done hands-on testing and also the commissioning of the medium voltage switchgear. However, this training particularly will be explaining different components and different characteristics of the medium voltage switchgears. So we will not be focusing in this training about different commissioning tests, commissioning methodology that are being performed. So anyone who like to know about the medium voltage switchgear, different components and how they are installed in it from scratch to the master level, they can really join our training. So we will continue. I will give an introduction about the switchgear in this intro. So what is a switchgear? A switchgear is an electrical power system. In electrical power system, switchgear is composed of electrical disconnect switches, fuses or circuit breaker used to control, protect, isolate electrical equipment. Switchgear is used both to de-energize the equipment, to allow work to be done, and to clear fault downstreams. So switchgear is basically a control device, a protection device, and it's a combination of all these things. So you can see how the switchgear look like. So I will give you a background now that why we need a specialized terminology or specialized kind of equipment in the medium voltage levels. So if you consider a switchgear, you will see this switchgear first of all is coming in a metallic enclosure. Second thing is, here in the center you can see this is the circuit breaker compartment, and circuit breaker is installed here. So circuit breaker means that is purely a switching device is installed in this MV switchgear. So the control is possible through this buttons as well. So this is emergency push button. Further, if you see here, you can see this switchgear has also relay. So it means that the switchgear, which is metal enclosed, also has a relay in it. So the relay is also installed in the same compartment. Metering, you can see this is the energy power demand meter, or you can see different values of energy here, and you can see this is again the digital power meter. You can see voltage, current, and all other values here. Further, if you come down, you can see this is the mimic. So the mimic is also together with the protection control here, and the top you can see this is the device that is a capacitive voltage indicator, and this device is installed to show that the cable is live or not live. So if the cable is live, the LEDs will blink here on and off, and you operator will know that the cable is energized or not energized. Downside, you can see there are switches which are there to issue the closing and tripping commands, and these are the indications. So we can see this is basically a switchgear, which is a combination of the breaker, and you can open this door and you can rack out and rack in the breaker as well. Further downside, the VTs are placed, earthing switch access is also available at the downside, and the back side of it the cable is connected. And if you see further, you can see the bus bar arrangement is also inside this. So switchgear is the combination of all protection, control, and the high voltage equipment. So this, we are combining all these things in a single package. However, they have separate compartments that we will learn later, but we are combining all this, and the work is because the ultimate aim is to make a optimized design and control a cost. if you see an AIS, air insulated switchgear, so you can see this is example of AIS, that is air insulated switchgear. So in the AIS you can see the switchgear is separately installed and the protection devices are separately installed, and these are in the relay room. So this is a very expensive system, but this become feasible when the voltages are increased. So you can see this example of GIS. So this is the gas insulated switchgear. The size is now reduced, but still you need a separate protection panel in that. Also, if you are going for AIS and GIS, apart from the protection panels and separate switchgear, you need a separate control panel as well in the control room. So here you can see all the indications are there, alarms are there, you can see the synchroscope is also there. So you can you need to have all this equipment. So by installing MV switchgear, we are optimizing the cost, we are optimizing the space or footprint requirement. So that's why you will see the MV switchgears. You can see these switchgears, which are a combination of all these things we are calling it, and these are installed mostly at the medium voltage level. But this also comes with an hazard. Hazard is because if the operator is doing operation in front of the switchgear, then there could be the hazard of flash. That's why it's always recommended to make a remote control panel as well with the MV switchgear. So this is a disadvantage of the MV switchgear. So this is all about an intro. So later we will learn together about different compartments of the switchgear, different type of breakers, and different characteristics of the MV switchgear. Thank you very much.